Hello everyone. Assalamu alaikum. This is Mohammad Jahangir Hussain from MJ's Math Cafes. Today we are going to solve a mechanics paper from Cambridge International AS and A level, May June 23, variant 43. So without further ado, let's get into the question paper. Okay, this is the paper, May June 23, variant 43, paper 4, mechanics. So let's start with the question number one. Question number one is the two particles P and Q of mass 0.1 kg and 0.4 kg respectively are free to move on a smooth horizontal plane. Particle P is projected with a speed 4 meter per second towards Q, which is stationary. After P and Q collide, the speeds of P and Q are equal. Find two possible values of the speed of the of P after the collision. So now let's present this information on a rough diagram. So this is particle P, particle P, particle Q. These are the two particles. Initially Q is at rest. P, Q, mass of P 0.1 kg, mass of Q 0.4 kg is projected towards Q with a speed 4 meter per second, and Q is initially at rest. After the impact, both particles have equal speeds. So speed, let's say V. Now, will they move in the same direction after the collision? Yes. So there are two possibilities. Q can only move away from P, but P can move towards Q, or it can also move in the opposite direction. So P has two possible direction of motion after the collision. So we have to consider both of them to find two possible values of the speed of P after the collision. Okay. Now let's apply conservation of linear momentum here. Conservation of linear momentum states that sum of momentum before collision equal to sum of momentum after collision. Okay, so since in no momentum is a vector quantity, you have to consider one of the direction to be positive. Let's say initial direction of P, initial direction of motion of P is positive. So right direction is positive. Now apply sum of momentum before collision 0.1 mass of P into its velocity plus 4 plus 0.4 into mass of the Q 0.4 times velocity of Q, which is 0. That's sum of momentum before collision, and after collision mass of P times its velocity. Now the velocity of P can be either positive or negative. Plus mass of Q times its velocity, which is V plus V. Now we have two possible equations. 0.4 equal to plus minus 0.1 V plus 0.4 V. Now, if we consider positive, then we have 0.4 equal to 0.5 V. So V is 4 by 5 meter per second. Now, if we consider negative, then we have 0.4 equal to 0.3 V. So V is 4 by 3. So these are the two possible speeds of P after the collision. So speed is of P 4 by 5 meter per second or 4 by 3 meter per second. Okay, that's question number one. I hope The concept is clear to you. Now let's move on to question number 2. Okay, in question 2, a car of mass 1500 kg is towing a trailer of mass 10 kg along a straight horizontal road. The car and trailer are connected by a tow bar which is horizontal, light, and rigid. There is a resistive force of F Newton on the car and a resistance force of 200 Newton on the trailer. The driving force of the car's engine is 3200 Newton. The acceleration of the car is 1.25 meter per second square. The tension in the tow bar is 300 Newton. Now find the value of M and the value of F. Okay, for this one, let's draw a rough diagram of this information. Okay, this is the horizontal road. The car is modeled by a particle. The trailer is also vertical. Now they are connected by a light horizontal and rigid tow bar. Now there are forces, driving force G of 3200 Newton on the car, resistance of F Newton on the car, resistance of 200 Newton on the trailer, there is tension on the tow bar, and T equal to 200, T equal to 300 Newton. The car, this is the trailer. Now we have the forces acting horizontally on the car and the trailer. If we apply the Newton's second law on each of them, for car, and there is acceleration. Acceleration of the car and the trailer will be same since they are connected by two bars, which is naturally inextensible. Okay? For car, Newton's second law is, we apply Newton's second law, it will be d minus t minus RT equal to ma. So G, driving force on is 3200 minus tension 300 minus RT, which is F, mass of the car, 300, acceleration is 1.25. So we have F equal to, calculate F, we will have is 1025. That's the value of F. Since the resistive force is F Newton, so F is the number only. Now, if we apply the Newton's second law for trailer, we have the equation T minus RT equal to M if T is 300, RT is 200 equal to M unknown into 1.25. So M is equal to 80. So mass of the trailer is 80 kg only. Okay, that's for question number 2. Now let's move on to question number 3. In question 3, you see, question 3 says, smooth ring of mass 0.2 kg is spread on a light spring ARB. This is important. The ring is smooth. The ends of the spring are attached to fixed points A and B with A vertically. B. The spring is taut and the angle ABR is 90 degrees. The angle between the chord AR of the string and the vertical is 60 degrees. The ring is held in equilibrium by a force of magnitude x Newton acting on the ring in a direction perpendicular to AR, as shown in the diagram. We have to calculate the tension in the string and the value of x. Now the thing is, since the ring is smooth and the string is taut, so on both segments of the string, the tension magnitude of tension will be same. On both segments of the string, magnitude of tension will be same because the ring threaded on the string is smooth. So we have the forces coming from the segment of the string on the ring. There is applied forces. Apart from this, there is also weight of the ring, 2 meters. Now, to find the value of t and x, we need to resolve these forces in two directions. Let's say the horizontal direction be the x-axis, this x-axis, and the vertical direction is the y-axis. In that case, you need to resolve on the tension in the segment AR and the applied force, because the other T, which is along BR, is horizontal and weight is vertical. Now, first, let's resolve the tension on the segment AR. In that case, the angle that T makes with the vertical is equal to 60 degrees. That's alternate angle. And what about the angle of X? Now you see the angle between X and the vertical should be 90 minus 60, that is 30 degrees. Okay. Now let's resolve T first, then component of T will be vertical component is E cos 60 and horizontal component is E sin 60. Component of X will be horizontal component. See, the angle it makes with the vertical is 30, so horizontal component will be X sin 30 and vertical component is X cos 30. So now we have resolved these two forces into components. Now let's equate horizontally and vertically because the string is held in equilibrium. So forces are balanced. If you consider the horizontal forces, consider horizontally, we have x sin 30 equal to t plus t sin 60. So x sin 30 half is t plus root t by 2. X is t plus root 3t. Now, if you resolve vertically, we have upward x cos 30 plus t cos 60 equal to downward 2. So x is 20 plus 50t, 20 plus root 3t equal to into cos 30, which is root 3 by 2, plus cos 60 into t, that's half t equal to. Now take t common from here, so we have root t plus t by 2 plus half equal to 2, so t is 2 divided by 2 plus 3. That's the value of T, the tension in the string. If you calculate it, we'll have How much it is? 2 divided by 2 plus root 3. That's 0.535898. Keep it correct to 3 step. This is 0.53. Remember, why to calculate x, you need to use the value of t, but you keep use the value, exact value, while calculating x. So 2t, x is 3. Take common t times 2 plus root 3. So that is 2 by 50 times 2 plus 50. So that cancel out. X is equal to 10. Okay, this is the value of x and t in question 5. That's it. Now let's move on to question number 3. Now question number 4. In question 4, you see a lorry of mass with 300 kg moves on a straight horizontal road in a direction from A to B. It passes A and B with a speed 20 meters per second and 25 meters per second respectively. The power of the lorry's engine is constant and there is a constant resistance to motion of magnitude 6,000 meters. The acceleration of the lorry at B is 0.5 times the acceleration of the lorry at A. So that power of the lorry's engine is 200 kilowatt and hence find the acceleration of the lorry when it is traveling at 20 meters per second. That is the acceleration at point A. So what we see here, it is moving along a straight horizontal road while passing through A. At A is acceleration while passing through A. Let's say this point A, this point B, and it is moving towards B. Speed at a 20 meters per second. And it has the driving force. The power is constant. So driving force equal to P by V. That's P by 20. And there is a constant resistance of magnitude. Resistance is 6,000 Newton. Then resistance acts are 6,000 Newton. And there is driving force. Here, while it passes through B, its speed is 25 meters per second. Now, acceleration at A is acceleration at B. The acceleration of lorry at B is 0.5 times. So, if the acceleration at A is, let's say A, then acceleration at B is half A, 0.5 A. So, these are two results. Now, we have here, we need to find the value of P and the acceleration at A. Okay, now let's see. Let's set the equation here. For the lorry, the equation at A, to apply the Newton's second law, it will be D minus R equal to MA. D is P by V. V is 20 minus 6,000 equal to M, 15,000 into V. Okay, that's equation 1. Now, at B, the equation will be same equation, D minus R equal to MA. D is E by 25 minus 6,000 equal to 1,500 into, not 15,000, 15,000. 15,000 into 0.58. So that's equation number 2. Now apply, multiply by equation 2 by 2 and add with equation 1, we will have 2p by 25 minus 12,000 equal to 15,000 a. Equation 2 and 2. Now equate these two. If from equation 1 we have 15,000 a, here we have 15,000 a, so these two are equal. So get 2p by 25 minus 12,000 equal to p by 20 minus 6,000. So we have plus p by 25 minus p by 20 equal to 12,000 minus 6,000, that's 6,000. So from this one, p 2 by 25 minus 1 by 20 equal to 6,000. So p equal to 200,000 watts. That's 200 kilowatt. Now acceleration will be 1 by 15,000 times p 200,000 by 20 minus 6,000. So acceleration is 4 by 15 meter per second. That's the value of p and value of the acceleration. Now let's move on to the next part. The lorry begins to ascend a straight hill inclined at 1 degree to the horizontal. It is given that the power of the lorry's engine and the resistance force do not change. Find the steady speed of the hill that the lorry could maintain. Here you see, if you draw it roughly, this is the lorry and forces. Okay, what are the forces? Here we have driving force, we have resistance, and in addition to this, there is component of weight 15,000 d sine 1. Okay. Now it is moving with constant speed. So acceleration is 0. We need to find the constant speed, steady speed. Now you see, since acceleration is 0, so along the hill, the resultant force is 0. So G equal to R plus G sine of. Okay. Alpha is 1 degree. So D is P by V. P is 200,000 by V equal to R 6,000 plus 15,000 into 10 into sine 1. Now, from this one, V is equal to 23.2 correct to PSF meter per second. Okay, that's the value of V. Okay, that's it. Now let's move on to the next question. Next question is, a particle starts from rest at point O. A particle starts from rest at point O. Rest from point O and moves in a straight line. The acceleration of the particle at time t-second after leaving O is a meter per second squared, where a equal to kt to the power half and t is between 0 and 9. So k is a constant. The velocity of the particle at t equal to 9 is 1.8 meter per second. so that k equal to 0.1. So acceleration is given, so you need to find the expression for velocity because the velocity at t equal to 9 is given. So e equal to integration of acceleration, and that is integration of k to the power half dt. So it is a to the power 3 by 2 divided by 3 by 2 plus 3. So 3 is 2/3 a to the power 3 by 2 plus 3. Now substituting, if the particle started from this T0, V0, substitute T0, V0, we have 0 equal to 0 plus T, so T is 0. Now T9, V is equal to 1.8. So use this value 1.8 equal to 2 by 3k into 9 to the power 3 by 2 plus 0. So 1.8, 2 by 3k into 27. So that is 18. K is 18k equal to 1.8, k is 0.1. That we have to solve. Shown here, that's part A. Now let's move on to the second part. For t greater than 9, the velocity v meter per second of the particle is given by this, so that the distance traveled in the first 9 seconds is 1/10 of the distance traveled between t equal to 9 and t equal to 8. So to find the distance traveled in the first 9 seconds, let's find it first, then we find the distance traveled between 9 and 18 seconds, and find the ratio. Okay? S 0 to 9. Distance traveling. No distance is integration of v over the limit of 0 and 9. So 0 to 9, v is, remember, k is 0.1, v is 2/3 k, that is 2 into 2 by 3 into 1 by 10, that's 1 by, let's write it here, v is 1 by 15 e to the power 3 by 2. So 1 by 15 e to the power 3 by 2. To get this, we have 1 by 15 e to the power 5 by 2 divided by 5 by 2. And the limit is 0 and 9. 2 by 75 e to the power 5 by 2. If we substitute 9, we have 2 by 75 times 9 to the power 5 by 2 minus 2 by 75 into 0 to the power something is 0. So we have, this is equal to 6.48. 6.48 meter, that is the distance traveled. Okay. Now, to find the distance traveled between 9 and 18 seconds is the integration of that. 9 to 18, v 0.2 t minus 9 whole square plus 1.8. But there is a question whether velocity particle comes to rest between this interval or not. But you see, the velocity here is a quadratic expression of t, and it has minimum at t equal to 9, velocity is minimum. So afterward, velocity increases from this, so it will always remain positive during this interval. So there is no issue of returning. So you integrate in this interval, you get the distance traveled in this interval. So we have, integrate this one, we have 0.2 times t minus 9 equal to the power 3 by 3 plus 1.8 t, limit 9 to 18. So if you substitute 0.2 by 3 into 18, 18, if substitute 18 here, we have 9 cubes plus 1.8 into 18 minus, we substitute 0.9, we have 0 plus 1.8 into 9. And that is equal to 64.8 meters. So the ratio is 9 to 18 by S0 to 9 is 10. So yes, distance traveled in the first 9 seconds is 1/10 the distance traveled between 9 and 18 seconds. That we have to show. Okay, that's part B. Now let's move on to the next part C. Here we have to find the greatest acceleration of the particle during the first 10 seconds. Remember, the expression for acceleration is 0.1 t to the power half for 0 to 9 seconds. Yes, for 0 to 9 seconds. And the acceleration in the next period is dv by dt. So if you differentiate the next expression for velocity, it will be 0.4 times e minus 9 e minus 9. Okay, this is for t greater than equal to. From the first equation, you see as time increases, acceleration increases. So greatest acceleration will be from the first equation at t equal to 9. So, so let's find it directly at t equal to 9. The acceleration from the first one is 0.1 into 9 to the power half, that's 0.3. Okay, is our second equation for t greater than 9? Yes, the second equation is not for t equal to 9. Now, remember during the first 10 seconds and the second acceleration equation of acceleration, you see from the second equation of acceleration, you have t equal to 0, t equal to 9, acceleration is 9, although therefore t equal to 9, this acceleration is not valid, or t equal to 9, the first one is valid. And here, after t greater than after 9 seconds, the acceleration increases, and since we'll find the acceleration after 10 seconds, so from this one, this equation, the greatest acceleration will be at t equal to 10. So at t equal to 10, acceleration is 0.4 into 10 minus 9, that's 0.4 meter per second square. So during the first 10 seconds, greatest acceleration is at equal to 10, and that is 0.4 meter per second square. That's the greatest acceleration. Okay, that's part 3. Now let's move on to the next part. Oh no, there is no further part, so move on to the next question number 6. In question 6, you see an elevator is pulled vertically upwards by cable. The elevator accelerates at 0.4 meter per second square for 5 seconds, then travels at constant speed for 25 seconds, then the elevator then decelerates at 0.2 meter per second square until it comes to rest. Find the greatest speed of the elevator, hence draw velocity time graph. So you see, this greatest speed at t equal to 5 seconds, and then it is maintained up to for the next 25 seconds. Okay, and during the first 5 seconds, it is accelerates uniformly at 0.4 meter per second square. So you can apply t equal to e plus t for the first 5 seconds. Initial velocity, since it is starting from rest, the initial velocity is 0. And acceleration 0.4 times 5. So, although it is not given here that the elevator starts from rest, but since the elevator accelerates and is pulled up by a cable, naturally, we assume that it is starting from the ground level, and so from the turning point, the initial velocity obviously is zero. It was at rest, that's why we have to pull it up and accelerate for 5 seconds. Okay, that's the good speed. Now there is another thing. Allow it decelerate to come to rest from the speed of 2 meters per second to find the one for last part, deceleration time, we have v equal to u plus at. See, velocity comes to rest, the v is zero, initial velocity is the greatest velocity 2, and the deceleration is 0.2, and c is the t equal to 10 seconds. Okay, now let's draw the velocity time graph. Yeah, this is velocity, this is velocity, this is for time. Now we have constant acceleration for 5 seconds, then constant speed for next 25 seconds, then we have deceleration for the next 10 seconds. So that's the velocity time graph. The meter per second, and this time in seconds, this is 2, this is 5, this is 25 plus 5, that's 30, 30 plus 10, 40. Remember, with these elevator travels at constant speed for 25 seconds. The constant speed is 25 seconds. So the speed it is decelerating at the end of 5 plus 25, that's 30 seconds. The total traveling time is 30 plus 10 per second. That's the velocity time graph. Now, you have to find the total distance traveled by the elevator. Okay, so total distance. So the total distance will be the area under the curve. You can use it, find it directly, or you can find in the by segment wise for the triangle, then rectangle, then the triangle again. So total distance you can use directly the total area, the area of the trapezium, or triangle or rectangle or triangle. Okay. If you use the area of the trapezium, then the length of the parallel sides A and B, A, B in this trapezium, the parallel sides are this and this. So if you consider the greatest one to be A, that's 40, and B is 25, H is this one. This one is the H. So we have R times 40 plus 25 into H is 2, so that's 65 meters using the trapezium. If you use the triangle, rectangle plus triangle, this is the half times 5 times 2 plus 25 into 2 plus half into 10 times 2. So that is 15 plus 50, that's 65 meters. Either way, the answer will be 10. Okay, that's part B. Now, let's move on to the last part. Here, you see the mass of the elevator is given. Mass of elevator is 1200 kg, and there is a crate of mass m kg resting on the floor of the elevator. Given that the tension in the cable and when the elevator is decelerating, okay, so it is decelerating at 0.2 meter per second square for the final 10 seconds. Now, while this is decelerating, the tension in the cable is 12,250 Newton. Find the value of M. Now, let's see what happens when it decelerates. There is tension coming from the cable. There is total weight, which is 1200 plus mass of the crate times and it is moving up with deceleration. So minus on that is minus 0.2. Okay, minus 0.2. So if we apply the Newton's second law here, it is moving up F equal to ma. So F is T minus width, that is 12,000 plus 10, plus 10 m, put it inside the bracket, equal to 1200 plus m into minus 0.2. And we know the value of t, 12250 minus 12,000 minus 10 m, and there is minus 240 minus 0.2. So from this one, m is equal to 50. So that's the value of m. Okay, that's part C. Now let's move on to the next part. Find the Okay, then in part D, find the greatest magnitude of the force exerted on the crate by the core of the elevator in a state its direction. Now, if you look at the crate and the force experienced by the crate, these are the weight of the crate, that's mg, that's 50 g, and there is resistance coming from the floor of the crate. Now, what will be the value? Greatest value of R. Why? When the acceleration is maximum, the since it is moving up, so let's say upward acceleration. And see, the equation for Newton's second law here will be R minus mg equal to ma, that's 58. So R is 50g plus 58. So what will be the greatest value of R here? R will be greatest when the G is constant here, G is constant, so only variable here is A, and there are three values for A here. Well, accelerating A is 0.4, A is 0.4, while maintaining constant speed A is 0, and while decelerating A is 0.2. The greatest of this is 0.4, so R will be greatest when it is accelerating upward, and that greatest value of R will be, greatest R is 50 into 9.8, 50 into 10, that 50 into 10, that's gravitational acceleration plus 50 into 0.4. So that is 120 meters. Okay, that's the figure. Okay, that's part D. Now let's move on to the next part. Next question, question number 7. In question 7, you see diagram shows the vertical cross-section XYZ of the rough side. Rough slide. The section YZ is a straight line of length 2 meters inclined at an angle alpha to the horizontal, where sin alpha is 0.2x. The section YZ is tangential to the curve at curved section XY at Y, and X is 1.8 meter above the level of Y. A child of mass 25 kg slides down the slide starting from base at X. The work done by the child against the resistance force in moving from X to Y is 50 joules. So work done while moving from X to Y against resistance, work done is 50 joules. We have to find the speed of the child at Y. So the child starts from rest at X. So E is 0, E is 0 here. You have to find B. How much is B here? Now, what is the changes occurring here? You see the child lose its potential energy, then its kinetic energy, and there is work against resistance, so you can apply. You can find these three separately, then use the energy principle, work energy principle. Let's see how much is the dp loss. dp loss equal to mg, you know the vertical height, so mg into 8. M, mass of the child is 25 kg, so mg is 350 into A is 1.8 joule. And work against resistance is 50 joule. Then we have K gain. K gain is half into 25. B square minus C square is 0. So half into 25 into B square. Now, if we apply the work energy principle, so loss equal to gain plus work against resistance. Loss, dp loss is 250 into 1.8. K gain is 25 by 2 D square plus work against resistance 50. So from this one, we have E is 4 root 2 or in exact form, E is 4 root 2 meter per second, or if it is calculated, it is 5.60 meter per second. That's the speed of the child at y. Okay, now let's move on to the next part. In the next part, it is given that the child comes to rest at J. Use an energy method to find the position of friction between the child and voyager, giving your answer a reflection as it and in its simplest form. So what is happening from Y to Z? It is losing GP again, and then the child comes to rest at Z, so it also losing kinetic energy. So GP loss, V loss equal to work against friction. How much is the friction here? You see, at any point, R equal to V cos alpha. So friction equal to mu R times mu R. So first calculate friction. R equal to mg cos alpha. Mg, that's 250 cos alpha. How much is cos alpha? Sin alpha is 0.28. Let's consider writing the triangle to find the exact value of cos alpha, since we have to find the value of P in exact fraction. So sin alpha is 0.28, right? So that's 7 by 25. So opposite 7, 25, now use the regular tool. Fill them to calculate the adjacent, which will be 24. Cos alpha is 24 by 25. Now, we have cos alpha is 24 by 25, so that's R is 240 Newton. Then friction, so the mu R 240 mu, so then GP loss equal to 250 into sin alpha into the distance to see the distance along the inclined plane is 2. So sin alpha is 0.28. So 500 into cos 0.28. Okay. Then we have work against friction, work against resistance. It is friction into the distance to 480 mu and a loss of v square point v square half into 25 A is 4 root 2, 4 root 2 square, that's minus B square, B is 0. 400. Okay, now apply loss equal to gain plus work against resistance. Since there is no gain, so it is 0. And loss, there are two loss, dp loss plus A loss. dp loss is 500 into 0.28. A loss is 400. And work against friction is 480 mu. So mu is 500 into 0.28 plus 400, 540 into 480, 9 by 8. That's the coefficient of friction in exact terms. Okay, that's the value of mu here. So that's part B, and that's the end of the question. I hope all the explanation is clear to you. If there is any confusion at any part of the paper, don't forget to mention it in the comment section. I'll try to attend it. I'll respond to your query as soon as possible. Okay. If you think this video is helpful, please don't forget to give a like to the video and subscribe to the channel. Hope to see you in the next video. Until then, Allah Hafiz. Assalamu alaikum. Yeah, man.